All right, this is AP Calculus AB Section A. This is Unit 3, Lesson 3. And we're going to look particularly at end behavior. End behavior. So I'm going to write a function on the board here. Let's do the limit. Well, not the limit. Let's just do end behavior of a function. So f of x equals x cubed minus 7x plus 3. Okay? Divided by, or over, x squared plus 4. Let's do x, x squared plus 4. X squared plus 4. Okay? In this particular case, we could try to find the limit as x goes off to infinity. And you're going to find that because the power on the top is greater than the power on the bottom, the degree of the polynomial on the numerator is greater than the degree of the polynomial on the denominator. This whole thing is going to go off to positive infinity in both directions, right? As x goes to negative, well, actually, it's going to go off to positive infinity on the right and negative infinity on the left, because it's going to behave like x, y equals x, in that regard. But what is the end behavior? What does this function model? In order to determine the end behavior, we're going to do something called long division. Fraction or rational expressions long division. Okay, long division. And here's what we do. We write the numerator inside the division sign. We call it the divide end. So x cubed. Now note I'm missing an x squared, so I'm going to put in 0x squareds minus 7x's plus 3. That's very important, a very important step in long division. You need to insert 0 placeholders for missing powers of x. Okay, and the same thing for our quotient, our divide end, our dividend divisor. This is the dividend, and this is the divisor. X squared plus 0x plus 4. Okay, so we have something like this. All right, and so if you recall the steps for regular long division, they involve taking a guess as to what I need to multiply the divisor by to get the dividend. Right, so we're going to take a guess here, and I'm going to say that I think I need to multiply by x. Okay, and I'm going to put that right here. And let's do that. But remember to distribute. X times x squared is x cubed. X times 0x is minus 0x squared, which is 0. X times 4 is plus 4x. And now the next step is to subtract, which means change all the signs and add, right? That subtracting is adding a negative. So x cubed minus x cubed is 0. 0x squared minus 0x squared is 0. Negative 7x and negative 4x is negative 11x. Okay, and now we're going to bring down the next term. Now I just made one that didn't turn out. This wasn't the best example. It would have been nicer if I'd have had an x squared term in here. Okay, but let's bring down the next term. Bring down plus 3, and we have negative 11x plus 3. Now I can't multiply x squared by anything to get this. So this is the remainder. Okay, this is the remainder. So we're going to write the remainder over the divisor. So our solution here, our rewritten formula is this. F of x equals x plus negative 11x plus 3 all over x squared plus 0x plus 4, or x squared plus 4. Okay, x squared plus 4. Now hopefully you recognize what's going to happen now as x goes off to infinity or negative infinity. As x goes off to positive infinity, this whole thing, because the degree of the polynomial in the denominator is greater, is going to go off to 0. And this whole thing is going to behave as y equals x. So the end behavior as x goes to positive infinity is y equals x. As x goes to negative infinity, it's also y equals x, which goes off to negative infinity. So y equals x is the asymptote, the end behavior, and it's we call it a diagonal asymptote. So let me show you that real quick here. All right. So I'm going to graph my original function, y equals x cubed minus 7x plus 3 all over x squared plus 4. Okay, and I'm going to graph my end behavior, y equals x. Okay, and as you see, the blue graph, which is the original function, as we go out to the ends, more and more approximates the green line, the green diagonal line. Okay, let's do one more, because that one turned out kind of trivial. Let's do one more, if you can bear with me here a little bit. Okay, and let's say we have f of x. F of x equals x cubed plus 4x squared minus 2. And we've got x plus 3. X plus 3. Okay? And hopefully it's not a factor of the original. I don't think it is. So let's do the long division. Long division, which isn't necessarily terribly long. X plus 3 into x cubed plus 4x squared. There's no x terms, no constant term, or no first order terms, so we're going to do 0x minus 2. Okay, x times x squared is x cubed. So x squared times x is x cubed. X squared times 3 is 3x squared. Subtract, meaning change both sides, and add. 4x squared minus 3x squared is x squared. Bring down the next term, plus 0x. X times x is x squared, so I'm going to put an x here. X times x is x squared. X times 3 is 3x. Subtract, change both signs, and add. 0 minus 3x is negative 3x. Bring down the next term. And we can still go on here. It looks like negative 3. Negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. Change, subtract means change, meaning change both signs and add. Negative 3x and 3x is 0. Negative 2 and 9 is 7. So I'm going to write the remainder over the divisor. So we're going to say f of x equals x squared plus x minus 3 plus 7 over x minus 3. Okay, and again, consider what happens as x goes off to a positive infinity. As x goes off to positive infinity, this whole 7 over x minus 3 is going to go off to 0, right? As x goes off to negative infinity, this whole thing's going to go off to 0 as well, just from the left side. So this is what the function's going to look like out toward the ends. X squared plus x minus 3. Let's demonstrate it here. All right. And let's graph the original function. Y equals x cubed plus 4x squared minus 2 all over x plus 3. Okay. And let's graph y equals x squared plus x minus 3. Okay, and let's take a look at this in more detail here. The purple is the original function. Notice there's this asymptote, right, at negative 3. In fact, if I graph x equals negative 3, there's this asymptote right there. But other than that, the purple behaves like the black. And let's change the scale here a little bit so you can see it. Let's change our x-axis to go from negative 10 to positive 10. There we go. And now you can see it a little bit better. The black is the end behavior, and the purple is the original function. And as I go out further and further toward the right, it behaves more and more like that quadratic equation, x squared plus x minus 3. So hopefully that makes sense. Long division is the skill you need.